Capacity management refers to the act of ensuring a business maximizes its potential activities and production output at all times under all conditions. Companies must remain nimble enough to constantly meet expectations in a cost-effective manner. When we say capacity, it is a measure of capability of a manufacturing or service system to perform its intended function. It is measured by the amount of output that can be produced in a particular time period. Having sufficient capacity to meet customer demand and provide high levels of customer service is vital to a successful business and long-term economic sustainability. Capacity can be viewed in one of two ways. First, as the maximum rate of output per unit of time, or as units of resource availability. Capacity decisions are often influenced by economies and diseconomies of scale. Economies of scale are achieved when the average unit cost of good or service decreases as the capacity and/or volume of throughput increases. One way to achieve economies of scale is a focused factory. Without extensive investments in facilities and capacity, by focusing on a narrow range of goods or services, target market segments and/or dedicated processes maximize efficiency and effectiveness. These focused factories should have a few key products, a specific technology, a certain process design and capability, specific competitive priority objective, and particular market segments or customers and associated volumes. While when we say these economies of scale, these occur when the average unit cost of the good and service begins to increase as the capacity and/or volume of throughput increases. Operations managers must decide on the appropriate level of capacity to meet current short-term and future or the long-term demand. Clog courts are court systems in most major cities that are strained past their capacity with case backlogs and lag delays, often resulting in freeing criminals before they go to trial or incarcerating defendants who are subsequently acquitted for long periods of time. Capacity measurement in operations capacity measures are used in many ways in long-term planning and short-term management activities. The actual utilization rates at most facilities are not planned to be 100% of effective capacity. Some amount of safety capacity, or often called capacity cushion, defined as an amount of capacity reserved for unanticipated events such as demand surges, material shortages, and equipment breakdowns, is normally planned into process or facility. The formula for average safety capacity expressed in percent is equal to 100% minus the average resources utilization. This is based on average resource utilization over some time period. For factory, average safety capacity might be computed over a year, whereas for an individual workstation, it might be updated monthly. Capacity measurement is a work order that is a specification of work to be performed for a customer or a client. Capacity can be measured in various ways. Theoretical capacity is the maximum rate of output that can be produced in a period of time under operating conditions. However, theoretical capacity cannot always be achieved. Preventive maintenance or unanticipated events such as material delays, equipment breakdowns, employee absences, or worker fatigue will reduce the theoretical capacity. Effective capacity is the capacity that can be reasonably expected to be achieved in the long run under normal operating conditions. Its formula is capacity required, or C sub I, is equal to setup time, or S sub I, plus processing time, or P sub I, multiplied to order size, or Q sub I. The C sub I, or the capacity required, is the capacity requirements in units of time for work order. The S sub I, or the setup time, is the setup or changeover time for work order as a fixed amount that does not vary with volume. The P sub I, or the processing time, is the processing time for each unit of work order, and the Q sub I, or the order size, is the size of order in numbers of units. If we sum the capacity requirements over all work orders, we can compute the total capacity required. And its general formula is summation of required capacity is equal to the summation of setup plus the product of processing time and order size. For example, Dave's Dodgy Dungarees factory is capable of producing 145,000 dungarees a month. Last month, they produced 125 dungarees. Given is the actual output, which is 125,000 units. The potential output or the capacity is 145,000 units. Substituting the given amount to the formula, capacity utilization is equal to 125,000 divided by 145,000 multiplied to 100 is equal to 86%. In developing a long-range capacity plan, a firm must make a basic economic trade-off between the cost of capacity and the opportunity cost of not having adequate capacity. Capacity costs include both the initial investment in facilities and equipment and the annual cost of operating and maintaining them, much of which are fixed costs. The cost of not having sufficient capacity is the opportunity loss incurred from lost sales and reduced market share. Having too much capacity, particularly if demand falls, can be devastating. Long-term capacity planning must be closely tied to the strategic direction of the organization, what products and services it offers. For example, many goods and services are seasonal, resulting in unused capacity during the off-season. Complementary goods and services balance seasonal demand cycles and therefore use the excess capacity available. For instance, demand for lawn owners peaks in the spring and summer. To balance manufacturing capacity, the producer might also produce leaf blowers and vacuums for the autumn season and snow blowers for the winter season. And in capacity utilization, or the proportion of a business capacity that is actually being used over a specific period of time, the formula is capacity utilization expressed as percent is equal to actual level of output divided by maximum possible output times 100. Capacity requirements are rarely static. Changes in markets and product lines and competitions will eventually require a firm to either plan to increase or reduce long-term capacity. Such strategies require determining the amount, timing, and form of capacity changes. To illustrate capacity expansion decisions, let us make two assumptions. First, capacity is added in chunks or discrete increments, and demand is steadily increasing. There are four basic strategies for expanding capacity over some fixed time horizon. First is one large capacity increase. Next, small capacity increases that match demand. Then, small capacity increases that lead demand, and lastly, small capacity increases that lag demand. The strategy involves one large increase in capacity over a specified period. The advantage of one large capacity increase is that the fixed cost of construction and operating system setup needs to be incurred only once, and thus the firm can allocate this cost over one large project. However, if aggregate demands exhibits steady growth, the facility will be underutilized. The alternative is to view capacity expansion incrementally as in. The data illustrates the strategy of matching capacity additions with demand as closely as possible. This is often called a capacity straddle strategy. When capacity is above the demand curve, the firm has excess capacity. When it is below, there is a shortage of capacity to meet demand. In this situation, there will be short periods of over and underutilization of resources. The data shows a capacity expansion strategy with the goal of maintaining sufficient capacity to maximize the chances of not meeting demand. Here, capacity expansion leads or is ahead of demand, and hence it's called a capacity lead strategy. Because there is always excess capacity, safety capacity to meet unexpected demand from large orders or new customers is provided. Finally, the data presented illustrates a policy of a capacity lag strategy that results in constant capacity shortages. Such a strategy waits until demand has increased to a point where additional capacity is necessary. It requires less investments and provides for high capacity utilization and thus a higher rate of return on investment. However, it may also reduce long-term profitability through overtime, subcontracting, and productivity losses that occur as the firm scrambles to satisfy demand. In the long run, such a policy can lead to a permanent loss of market position. If short-term demand is stable and sufficient capacity is available, then managing operations to ensure that demand is satisfied is generally easy. However, when demand fluctuates above and below average capacity levels, the firm would have to choose between two basic options. First, they can adjust capacity to match the changes in demand by changing internal resources and capabilities, or to manage capacity by shifting the stimulating demand. When short-term demand exceeds capacity, a firm must temporarily increase its capacity or it will be unable to meet all of the demand. Similarly, if demand falls well below capacity, then idle resources reduce its profits. Short-term adjustments to capacity can be done in a variety of ways and are summarized as follows. First, add or share equipment. Next, sell unused capacity. Change labor capacity and schedules. Change labor skill mix. And lastly, shift work to slack periods. Revenue management systems consist of dynamic methods to forecast demand, allocate perishable assets across market segments, decide when to overbook and how much, and determine what price to charge different customer classes. These four components of RMS, the forecasting, allocation, overbooking, and pricing, must work in unison if the objective is to maximize the revenue generated by a perishable asset. The ideas and methods surrounding RMS are often called yield management. RMS integrate a wide variety of decisions and data into a decision support system used mainly by service-providing businesses. Some general approaches to influence customers to shift demand from periods without adequate capacity to periods with excess capacity or to fill times with excess capacity includes the following. First, vary the price of goods or services. Price is the most powerful way to influence demand. For example, hotels might offer cheaper rates on the weekend. In a similar fashion, manufacturers typically offer sales and rebates of overstocks to stimulate demand, smooth production schedules and staffing requirements, and reduce inventories. Next is provide customers with information. Many call centers, for example, send notes to customers on their bills or provide an automated voice message recommending the best times to call. Advertising and promotion. After holiday sales are heavily advertised in an attempt to draw customers to periods of traditionally low demand, manufacturer or service coupons are strategically distributed to increase demand during periods of low sales or excess capacity. Next is add peripheral goods and/or services. Fast food chains offer birthday party planning services to fill up slow demand periods between peak meal times. Extended hours also represent a peripheral service. Many supermarkets remain open 24/7 and encourage customers to shop during late night hours to reduce demand during peak times. And lastly, provide reservations. A reservation is a promise to provide a good or service at some future time and place. Typical examples are reservations for hotel rooms, airline seats, and scheduled surgeries and operating rooms. Reservations reduce the uncertainty for both the good or service provider and the customer. With advanced knowledge of when customer demand will occur, operation managers can better plan their equipment and workforce schedules and rely less on forecasts. The theory of constraints, or TOC, is a set of principles that focuses on increasing total process throughput by maximizing the utilization of all bottleneck work activities and workstations. The philosophy and principles of the TOC are valuable in understanding demand and capacity management. In the theory of constraint, a constraint is anything in an organization that limits it from moving toward or achieving its goal. Constraints determine the throughput of the facility because they limit production output to their own capacity. There are two basic types of constraints. First is the physical constraint. It is associated with the capacity of resource such as a machine, employee, or a workstation. And the other one is the non-physical constraint. It is the environmental or organizational, such as low product demand or an inefficient management policy or procedure. In general, the theory of constraint has been successful in many companies. As the TOC evolved, it has been applied not only to manufacturing but to other areas such as distribution marketing and human resource management.